This is the question for the topic of atomic and molecular physics, and the question is from GATE 2019 physics question paper. The question number is 48. The question is, a radioactive element X has a half-life of 30 hours. It decays via alpha, beta and gamma emissions with the branching ratio for beta decay being 0.75. The partial half-life for beta decay in unit of hours is how much? So in that question, we can see that basically they are asking about the half-life of the beta decay, and the radioactive element X, they are telling that it can decay via alpha, beta and gamma. Okay, and it has the half-life as 30 hours. And also it has given that the branching ratio for beta decay is 0.75. So, and they are asking that what will be the partial half-life for beta decay. So now what is branching ratio? Branching ratio, if I write here the definition, that can be written as, it is the fraction of particles which decays by an individual decay mode with respect to the total number of particles which decays. So, I mean, by mathematically, if I write it, it can be written as decay of beta, branching ratio for beta particle, if I write. Then decay of total. Total means alpha plus beta plus gamma. So the decay of beta divided by decay of alpha plus beta plus gamma, it is given as 0.75 in that question. So what is the meaning of that? The meaning of that is branching ratio of beta is 0.75. That means it can be written as like decay. Okay, so now decay, we know that decay is proportional to 1 by T. Half-life, right? T half. So we can write it like T half of total divided by T half of beta, because we can see here the decay of beta is there and in the numerator, and if the decay of beta is numerator, then obviously the half-life of beta will be in denominator, and similarly decay of total will be in as it is in a denominator. So in the numerator it will be T half of total. So T half of total is nothing but T half of X divided by T half of beta. Now you can see that if it is already given that T half of X is 30 hours and 0.75 is already given for the branching ratio of beta. Then what will be the value of T half of beta? T half of beta, we can write it like T half of X divided by 0.75. Then what will be the answer here? The answer will be like 30 hours divided by 0.75. So it will be little bit 30 into 100 divided by 75, and this is 10, 15, no, 2, 5, 25, right? Now 5, 2, 5, 5, 5, 20. So it will be 40. So for that question, T half of beta will be 40 hours, right? So the answer will be here 40. So to have the answer, what we need to calculate, we need to have the idea of a branching ratio. The branching ratio will be nothing but the decay of that particle divided by decay of total. So decay is inversely proportional to the lifetime. So decay is proportional to 1 by T half. So if I write of decay of beta divided by decay of total, then it will be like T half of total divided by T half of beta. So the branching ratio is already given 0.75 and t-half of x is already given as 30 hours. So from that relation we can have the value of t-half of beta, which is 40. So from that we can have the answer, half-life of beta particle.